Hello everyone, today I'm gonna talk about the exponential growth revisitedly. This topic has four subtopics. The first one is continuously compounded interest. The second one is continuously growth rate. And the third one is doubling time. And the last one is doubling rate. And now let's begin with the first one, continuously compounded interest. For this one has the formula which is P bracket 1 plus R over N to the power of NT. And in this formula, R represent an annual interest rate and T represent the time period. Like if it's set 2 years, so T it will be equal to, and then N is the number of time which interest is paid. If interest is compounded n time per year at annual rate R, then after T year, an initial amount P grows to this formula, that is P bracket 1 plus R over N to the power of NT. And so this equation can go to another formula, and if N is much greater than R, so the equation will be like P, actually it's like P bracket 1 plus R over N to the power of NT, and it will be equal P bracket 1 plus R over N to the power of T. And in this case, if N is greater than T, if N is greater than R, bracket 1 plus R over N to the power of N will be equal E to the power of R, and it will be as this solution as I wrote it here. In other words, if interest is compounded many times per year at a no interest rate R, then after T years an initial P grows to approximately PE to the power RT. So basically, P times E to the power RT is the amount that we would have if interest were compounded continuously. Let's move to the first example. Suppose that you have $20,000 in bank account that pay 4% annual interest, and if interest is compounded continuously, how much will be in the bank account of after 10 years? So let's solve. The solution is the continuously compounding formula shows that 20,000 compounded continuously for 10 years at 4% annual interest grows to become like this. $20,000 multiplied by E to the power of 0.04 multiplied by 10, and it will be equal around 29,836. The compound interest formula shows that 20,000 compound 2 times for 10 years at 4% annual interest grow to become this 20,000 multiplied by bracket 1 plus 0.04 over 2 to the power of 2 times 10, and it will be around 29,719. Now let's move to another example, and the question is how many does it take for money to double at 6% annual interest compound continuously? After T years, An initial amount P compound continuously at 6% annual interest grow to P times e to the power 0.06 times t, and we want this to equal twice the initial amount, then we must solve this equation by using the formula P times e to the power r times t equal 2 times p, because we want to take the money to double, right? So that's why it's 2 times p, because p is the initial amount. And this formula, it can cut p out of these two equation, and then e to the power r times t will be equal to, and if r is 0.06, then e to the power 0.06 times t will be equal to, and this equation can imply to 0.06 times t equal ln 2 by take natural ln into these two equations, and then t will be equal ln 2 divided by 0.06. And in this point I would like to calculate this by calculator, and the result will come out as 11.5 years, which means that is estimate around 12 years, which means that the initial amount of money will double in about 12 years. For an example, the question is what annual interest rate is needed so that money will double in 8 years when compound continuously. So the solution is after 8 years and initial amount P compound continuously at R%, annual interest go to P times e to the power 8 times R over 100. We want this to equal twice the initial amount, so solve this. P times e to the power 8 times r over 100 will be equal to p, because we want to make it equal twice the initial amount, right? And this solution, which equivalent to the equation e to the power 8 times r over 100 equal 2, because we can cut p out from the equation, which this equation will imply that 8 times r over 100 will be equal ln 2, and this will become out as r equal 100 ln 2 divided by 8, and let's use the calculator to solve this problem, and it will be 69.t divided by 8. The result will estimate around 8.6, hence about 8.6% annual interest will make money double in 8 years for this solution. Now let's move to the second main point. Second main point is continuous growth rate. Continuous growth rate operates like an interest rate that is continuously compound. Continuous growth rate. If a quantity has a continuous growth rate of R per unit time, then after T time units, an initial amount P grows to P times E to the power R times T. And let's talk about the example. Suppose a country population increased by a total of 7% over a 3-year period. What is the continuous rate for this country? By solving this solution, Step 1. Using continuous compounding interest formula. If interest is compounded continuously at annual interest rate R, then T years and initial amount P grows to an amount A given by A equal P times E to the power R times T. If R is not given, we can solve the above equation for R to obtain R equal natural log bracket A over P divided by T. And step 2. Substitute the given value to find the value of the missing variable. Notice that the initial amount is not given if we start with P over a 3-year period. It grows by 7% and the amount that it goes to 1.07 P and T is equal 3 years. And step 3. Substitute the given value to find the value of the missing variable. So A is equal 1.07 times P and T is equal 3. That means T years. And then substitute the above value into the formula. R equal natural log bracket A over P divided by T. So which means R equal natural log bracket 1.07 times P over P divided by T. And step 4. Substitute the given value to find the value of the missing variable. Now use a calculator to find the answer to above expression. Notice that P simply can cancel it out, which means R equal ln bracket 1.07 times P over P divided by T, and we can cancel P out. And if we use the calculator, the result will be R equal to 2.26%. For another example, what annual interest rate is needed so that money will double in 8 years when compounded continuously. So for solving this solution is after 8 years an initial amount P compound continuously at R% annual interest grow to P times E to the power 8 times R over 100 will be equal to 2 times P, because we want it as double, and this, which is equivalent to the equation E to the power 8 times R over 100 equal to, which implies that 8 times R over 100 equal ln 2. Thus, R equal 100 ln 2 divided by 8. Use the calculator to calculate this problem, and the result is 69.3 divided by 8, which is about 8.6. So about 8.6% annual interest will make money double in 8 years. Let's move to doubling time. Doubling time means how long it would take the interest rate for sum to double. In this meaning, doubling time has formula and it can be written by 70 divided by R, which means if R is 5%, then R equal 5. Then let's solve this question. The question is how many years does it take for money to double when compound continuously at 5% per year? By solving this equation, we will use the approximate formula for doubling time. Step 1. At R% annual interest compound continuously, money double in approximately T equal 70 divided by R year. Then step 2. Substitute the given value to find the value of missing variable. So R will be equal 5. And then substitute above value into the formula. T equals 70 divided by R, and it will be 70 divided by 5, and the result is 14 years. Come to the last point, doubling rate. Doubling rate is the annual interest rate needed for money to double in T years, which continuous compounding is approximately 70 divided by T%. For example, this formula shows that for money to double in 8 years, when compounded continuously, require about 70 divided by 8% annual interest, which equal 8.75%.